Dear ladies and gentlemen, dear colleagues, welcome to the EU Polar Cluster COP26 session on polar warming, global warming. We are here in Brussels and we hope that you will have a nice session with us. My name is Nicole Bibo. I am from the Alfred Wegener Institute of Polar and Marine Research in Germany, and I'm the coordinator of the EU PolarNet and the chair of the European Polar Board. It is well known that the polar regions are the sentinels of climate change and that the Arctic has already surpassed their 1.5-degree target. Therefore, it is really important to have a much closer look at the change which is going on in these vulnerable and pristine areas. We need to close important knowledge gaps and to develop adaptation and mitigation strategies. As I said, we are here in Brussels, and the EU is a major investor in polar research. It is supporting a lot of research projects, ranging from understanding polar climate systems with all its components to developing adaptation and mitigation strategies. The recently launched new EU Arctic policy stresses heavily the importance of polar research and also the importance of cooperation with all polar actors. In this session now, we are presenting the results from some of the EU Polar Cluster project. The EU Polar Cluster is a cluster of EU-funded research projects comprising currently 23 partner projects, 21 EU-funded research projects, and in addition, two important European organizations, the European Polar Board and the Svalbard Integrated Earth Observing System. Today, we will present the results from the projects SOCHIC, PROTECT, TPAX, EU PolarNet 2, and from the EPB. And before I start now to introduce the first speaker, I would like to introduce my co-moderators. Next to me is sitting Joseph Nolan from the European Polar Board, and here in the audience is Elena Ford from the British Antarctic Survey, who are organizing these sessions together with me. We will start now with the presentations, and we will have a discussion session after all the presentations have been given. But nevertheless, please start asking your questions via Slido. We will note them down and we will pass them to the speakers at the end of the session. And let's start now. It's my great pleasure to introduce our first speaker. The first speaker is Larissa Lorenzi. She is Policy Officer, Larissa, sorry for misspelling you, Policy Officer at the European Commission in the DG of Research and Innovation. Larissa is responsible for innovation for the healthy ocean, the Ocean Climate Nexus, and for polar research. And she is also involved in the Horizon Europe missions for ocean, seas, and inland waters. And Larissa will speak now about how does the European research policy supports polar research and international assessments such as the IPCC. Larissa, it's your turn.
Thank you very much, Nicole, and no worries about the Lorenzi part. So thank you very much for the invitation to join you at COP26. In DG Research, we are very, very proud and fully support the EU Polar Cluster and the EU PolarNet. As we all know, science is pivotal to deliver and navigate and accelerating the transformation of the European Green Deal agenda. And if I may quote our Vice President Timmermans speaking ahead of the COP, it is essential that we draw upon the weight of science to take bold steps forward for global climate action. In my presentation, I will focus on how exactly the European Commission supports the European science. If I can have my first slide, please, or the second. Thank you. So European research and innovation policy supports delivering the very ambitious European Green Deal, and it sets itself forth to do so via transparent, comprehensive, and balanced scientific evidence and innovative solutions. The European Green Deal recognizes the importance of research and innovation and the innovation principle, and all of this in promoting smart and future-oriented policies, as well as encouraging technological and social innovation. The current framework program, Horizon Europe, is the EU's key funding program, and in the next 7 years, it has a budget of 95.5 billion euros, which will target climate change. And for climate change, it has a 35% budgetary target, as well as help achieve the United Nations Sustainable Development Goals and boost European competitiveness and growth. Indeed, one of the novelties of Horizon Europe are the missions, and I'm closely linked to the mission on the oceans. And here I would just like to emphasize one of the cross missions lighthouse, which will be on the Atlantic and Arctic coastal areas, and will focus on a basin scale restoration portfolio of projects. This will target marine ecosystem restoration in coastal communities, which are particularly vulnerable to the risks of sea level rise, and that urgently need to adapt to ensure that their population and infrastructures are safe, climate-proof, and weather-resistant. In my next slide, I will focus in on the European polar research, which we are and have been constantly funding, and basically sustained scientific cooperation in the polar regions is of tremendous importance. And with the new renewed EU policy for the Arctic, the EU will have a stronger engagement in the region, and research and innovation will have a key role to play in protecting the Arctic and also supporting evidence-based policymaking and offering viable solutions. Research and innovation as well supports all of the climate actions and biodiversity policies and objectives of the Union. If I were to highlight just a few features of the European research and innovation and its role, is certainly to strengthen the scientific knowledge on global climate and biodiversity integrity, but also to support tackling the environmental and the climate change, in particular, looking at the most vulnerable ecosystems, such as the ocean and the polar regions, and taking these as a test bed for climate change impact and sustainable development. We very much look at identifying and deploying innovative solutions and sustainable solutions, which are based on a win-win strategy, which means that they are biodiversity positive with climate mitigation and adaptation co-benefits. And here we very much focus as well on nature-based solutions to ensure the integrity of the polar regions and the ocean. Our endeavor is that we contribute to better and evidence-based policy making and policy implementation, and we very often have policy feedback sessions with our projects and with the Commission services. We also support very much the international processes such as UNFCCC and the Convention on Biological Diversity, and we make substantial contributions to key international assessments such as those of the IPCC, IPBES, and so on. The European Union has an enhanced observer status at the UN, and the DGRTD is heading the EU delegation to the IPCC. In addition, with our framework program, we also support the IPCC Secretariat in preparing the IPCC assessment reports and facilitating the contributions and participation of the European scientists in the process. And last but not least, we hope that research and innovation helps lead in EU science diplomacy. On my last slide, I have put a few links and key information channels for you where you could follow the key developments. And with this, I wish you a very fruitful participation in the COP26, and I hand back the floor to you, Nicole. Thank you very much.
Thank you very much, Larissa, for this very interesting introduction, and especially also for keeping exactly to your time. That's wonderful. As I said, we will entertain the questions at the end of this meeting, and I'm now giving the floor to Frank Patin. He is a Belgian geologist, a glaciologist, and professor at the Free University here in Brussels. He's He's best known for developing ice sheet models and leading model intercomparisons. Frank is currently the chairman of the Belgian National Committee on Antarctic Research, and he's the vice president of the International Glaciological Society. Frank will speak about sea level rise, what is at stake beyond 2 degrees. Frank, it's your turn.
Thank you. If I can see the slides. Okay. So, sea level rise is one of the most visible and global impacts of climate change, affecting coastal infrastructure, coastal defenses, but also heritage, megacities, but also ecosystems and areas that don't have the ability to easily adapt, such as island states and developing states. Today, sea level rise is about 4 millimeters per year, which is more than double the amount that it was during the last century. Over the last 50 years, it was essentially the thermal expansion of the oceans due to the warming of the oceans that was the major contributor to sea level rise. Today, it's the melting of the ice that is the most important contributor, with an increasing importance of the Greenland and Antarctic ice sheets. And I will focus on those 2 ice sheets. The way ice is lost for both ice sheets is not the same. Greenland loses ice through surface melting around its periphery due to the higher temperatures we have at lower elevations. Antarctica, on the contrary, loses ice concentrated in one area, which is mostly West Antarctica, especially the Amundsen Sea sector, and that is in response to changes in ocean circulation and warming oceans. Now, the West Antarctic ice sheet is what we call a marine ice sheet. It's the ice rests on the bed, but that bed lies well below sea level. And in contact with the ocean, as this figure shows here, where the ice sheet is thinner, the ice starts to float and forms long platforms, which we call ice shelves, floating ice shelves. And these ice shelves, they play a crucial role in slowing down the flow of ice towards the ocean, and by a process that we call buttressing. It's a bit like a dam that you put on a river, or a cork that you put on a bottle. And so warmer waters that intrude erode these ice shelves and thin them, leading to an acceleration of the ice flow that is coming from upstream, which also makes the ice sheet loses mass. And this is something that is already observed. Here we see it to the left, how the ice shelves are already thinning at a pace of approximately tens of meters per decade. And then concomitantly, we have also, and that is what is shown in the right figure, we have a loss of grounded ice mass and an acceleration of these glaciers. And it's this ice loss that is responsible for a sea level rise. However, ice shelves do not only become weaker and thinner when the temperature increases, they can also break up very fast. Even within a few months, as is shown in this video animation and has been observed in Antarctica. They thus remove instantaneously the restraint or buttressing on the inland ice and make glaciers speed up rapidly. So it's the same thing as removing a dam or removing a cork on a bottle. Now, sudden breakup of ice shelves is shown here in an experiment of different ice sheet models that leads to a collapse of this West Antarctic ice sheet within centuries, with also the result of multi-meter sea level rise. This experiment here, which is a theoretical experiment, clearly demonstrates the importance of the health of these ice shelves, these floating extensions. And the process by which this rapid ice loss is operating, it's called the marine ice sheet instability, or MISI. Now I have to turn to another type of instability, because once these ice shelves are lost then you have an ice cliff that is in contact with the ocean that can reach several meters high. And due to the weight of ice, it can collapse in the ocean and retreat very fast, leading to sea level rise of more than 10 meters in the next coming centuries. Such a mechanism has been observed in the Antarctic as well as in the Arctic, but on a smaller scale than presumably would take place here on the West Antarctic ice sheet. This mechanism is called the marine ice cliff instability, or MICI. Now, this MICI is part of what we call deep uncertainty. It is possible to occur, but it is unlikely so. The MISI, the marine ice sheet instability, is better understood, but in order to kick in, you need to have the ice shelves sufficiently fragilized, either through the ocean warming or to surface melting. Even under present climate warming, these processes may play a role, but on long timescales. And with every degree of warming more, they may occur earlier in time and increasing the pace of sea level rise. So to conclude, staying below a temperature rise of 2 degrees keeps most of these ice shelves of the Antarctic ice sheet intact and within the safety band of those two processes, MISI and MICI, at least in the next few centuries. Above 3 degrees, rapid loss of ice of the West Antarctic ice sheet cannot be excluded and becomes even inevitable if we have high global warming of more than 4 degrees. Thank you.
Thank you very much, Frank. You are even better and even needed less than 6 minutes. I'm heavily impressed. Very impressive presentation. Thanks a lot.
Thank you.
We are going on to our next speaker, who is Tamsin Edwards. Tamsin is a British climate scientist and lecturer at King's College in London. She's a popular science communicator and writes for the Public Library of Science. Tamsin uses computer models to predict and study climate change with a particular interest in the impact of sea level rise on changes of the Antarctic ice sheet. Tamsin, it's your turn.
Thank you so much for having me to speak. If I could have the first slide, please. So I'll be talking about this question: how much can we limit losses from the ice sheets this century? And I'll talk about it from two dual perspectives. One is the main focus is the assessment of this question by the IPCC, the Intergovernmental Panel on Climate Change, for the recent 6th assessment report, of which I was one of the authors of the chapter given here. And the other is talking about the evidence base that lies behind this, including work that was done under the EU Horizon 2020 project called PROTECT, of which I'm also a member. Next slide. For the ice sheets, the key science informing the IPCC assessment was a project called ISMIP, standing for Ice Sheet Model Intercomparison Project. And here, many groups around the world ran hundreds of simulations for both the Greenland and the Antarctic ice sheets. Now, in a paper under a study under the PROTECT project, we combined and extended those simulations using statistical methods. There was also, if you go to the next transition, please, a second project for Antarctica that informed the evidence base here called LARMIP, which stands for Linear Antarctic Response Model Intercomparison Project, which ran simulations for Antarctica using different methods. So it was, if you like, an alternative approach. Next slide, please. And I will focus on comparing two different possible futures for the ice sheets under two different emission scenarios. The first is a plausible previous pathway of emissions, perhaps where we were heading for before or soon after the Paris Agreement, roughly a doubling of emissions by the end of the century, with an estimate for late 21st century warming of over 3 degrees and perhaps more than 4 degrees. And if you are familiar with the IPCC scenarios, that's the second highest of the 5, the core scenarios they use. And then I'll compare that with a scenario that successfully meets the Paris Agreement targets. So the peak warming during the century is actually just over 1.5 degrees, coming back down to 1.4 towards the end of the century, but with an upper end estimate of approaching 2 degrees, but extremely unlikely to exceed 2 degrees. And for that scenario to take place, the IPCC stated it would take immediate, rapid and large-scale reductions in greenhouse gas emissions. And that's the lowest of the 5 core scenarios used by the recent IPCC report. Next slide, please. Looking at Greenland first, the IPCC statements in the summary for policymakers were that continued ice loss this century is virtually certain, and that there's high confidence that the total ice loss will increase with cumulative emissions. This map shows the thinning predicted by the ISMIP project under very high greenhouse gas emissions. You can see the darker regions around the edge are where the ice has thinned the most. And in terms of the numbers, the lower of those 2 scenarios meeting the Paris Agreement would reduce the future losses from the Greenland ice sheet by more than half, reducing it from a contribution of 11 centimetres to sea level rise down to 5. And of course, there are many contributions to sea level rise aside from the ice sheets. Next slide, please. For Antarctica, the IPCC assessment was that continued ice loss this century is likely. It's a little more complicated for Antarctica, and the main projections are quite similar across emission scenarios. And that's because it's unclear how much increasing snowfall in the cold interior of the ice sheet will offset ice losses at the coasts through things like the processes that Frank talked about. And the map here shows predictions from the ISMIP 6 project, again, under very high greenhouse gas emissions. If you could click next, particularly here, you can see the Thwaites Glacier, which is where the photograph is also from. And the predictions here, as I say, are quite similar across scenarios, but still the lower scenario would reduce future losses by about 10% from 11 to 10 centimetres under the lower scenario. Next slide, please. But crucially, as Frank said, there is deep uncertainty about the ice sheets. Next slide. The key thing here is that there is deep uncertainty, which the IPCC represented with a low likelihood, high impact storyline, where under very high greenhouse gas emissions, and if we're unlucky with the ice sheet responses, if we see extreme melting of the surface of the Greenland ice sheet, if the Antarctic ice sheet is unstable in the ways that Frank described, the marine ice sheet instability and cliff instability as well, then we could see much higher central estimates that I've put here, 18 and 19 centimetres, but crucially even higher, an even bigger impact on the upper end estimates, so over 0.5 metre from each ice sheet, which of course would substantially increase coastal flooding around the world. So next slide, please. The storyline here has limited evidence behind it. So these are based on expert judgment and a single model predicting particularly this rapid ice cliff instability. So we really need new observations and new modelling to better understand the future of the ice sheets. And of course, we need to see how much emissions will be reduced by the pledges at COP26. So next slide. To summarise, you can actually click ahead 2 more times for the last text. We could reduce ice losses from putting the ice sheets together this century by 1/3 if we limit warming to 1.5 degrees compared with our previous plausible pathway. But there is a low likelihood, high impact storyline under high emissions, unlucky with the ice sheet response, that loses 5 times more ice. So we have to be flexible in our coastal flood management to account for a wide range of possibilities. Thank you.
Thank you very much, Tamsin, for these very impressive presentations. I'm always get a bit worried when I see these presentations, frankly speaking. Let's go on with the next speaker. We are now moving to the biological realm. The next speaker is Bruno Dennis. He is Associate Professor at the Marine Biology Lab here in Brussels at the Free University. His research focuses on polar biodiversity, biogeography, ecophysiology, and biodiversity informatics. And he's very involved in new approaches in marine conservation. Bruno will speak about Antarctic biodiversity under pressure, a race against time. Bruno, please.
Thank you very much. Thank you. So, yes, I call this presentation a race against time because we're regarding Antarctic biodiversity in a very special situation where we have the congruence of fast occurring environmental change, of quite a big deal of ignorance regarding this biodiversity. It's a region where we have a lot of gaps in knowledge, and at the same time, a biodiversity that is characterized by its uniqueness and its irreplaceability. So just to give you a new, maybe a different perspective on Antarctica and the way it's connected to other oceans, I like to show this to my students because it shows the connectivity of Antarctica here that you can see in the middle of the screen and how it's connected to the other oceans. So this has implication not only in terms of oceanography, but also in terms of biodiversity. So you could see the Southern Ocean, which surrounds the Antarctic continent, as a sort of washing machine, sending off biodiversity in all other oceans and connecting to them. In terms of biodiversity itself, the biodiversity that you find in Antarctica and the Southern Ocean is not what maybe some people still think, like an isolated place where only a few penguins survive. It's actually an ocean where there's a lot of biodiversity, a lot of richness, a lot of beauty as well. And in terms of conservation, what is interesting also is the fact that many of these species are endemic. You only find them in the Southern Ocean, and that they also display a set of really unique adaptations to an extreme environment, extreme but stable environment. So this biodiversity is irreplaceable. In terms of threats, there are quite a few threats which are making biodiversity scientists a bit worried about what's happening with ecosystems in the Southern Ocean. These threats come mostly from exploitation through fisheries. They come from indirect effects from ocean warming, acidification, and changes in sea ice and ice regimes in general. They also come from the introduction of invasive species, from tourist activities, and from actually also the activities of the scientists themselves. So what can we do against this? So in 2005, the Belgian Science Policy Office, so the Belgian government, actually took over the responsibility to build a very strong data infrastructure, which is called biodiversity.aq, where you can find and where all the data about Antarctic biodiversity is freely available on a single website. And this is a map displaying the magnitude of our ignorance. These little dots here show you the concentration of information, the concentration of knowledge we have for the Southern Ocean. And all the light blue dots you see here, hexagons, are actually places where we have close to nothing in terms of information about biodiversity. So a large part of the Southern Ocean is completely depopulated with information, actually. So this ignorance is a problem in terms of what we can do in terms of conservation, and what we can do also in terms of modeling and trying to predict what's going to happen with the ecosystems. Just a little slide here about synchronicities. So just to give you maybe a bit of an idea of the timescales about different things happening and why as a scientist, I'm quite worried about the situation. So if you want to describe a new species, and new species we find all the time in the Southern Ocean, this would typically take you 3 to 4 years of intense work to get a new species described. A research project, just to give you also an idea, maybe its lifespan would be around 5 years. And the time it takes to trigger a tipping point, I'm going to explain now, is around 15 years. So this is why I wanted to show you this. On the right side of this graph, you have what happens in terms of ecosystem composition. This is something that happened in the Arctic, so reaching a tipping point and going from one stable state of the ecosystem with one type of copepod at the beginning of the food chain towards the other type within a very small range of time. So you see here, from blue to red, it means that the ecosystem composition changes over time, and a complete change in the system architecture has occurred within 15 years only. This is extremely short. This is documented for the Arctic, and there's no reason why this couldn't happen in the Antarctic as well. This has far-reaching ends on the whole ecosystem and on the whole trophic systems. So what can we do about this? There are a few avenues, and this is maybe one of them. It's collective efforts. So here's an example of what we've done with a group of 70 scientists. This is an effort of research that has taken us 10 years and which has identified using tracking data, so satellite tracking data. You see all the spaghettis there on the top left figure. Thousands of tracking data sets for many species, all the species actually of marine mammals and birds we have for Antarctica, and this has helped us delineate and identify areas of ecological significance, which you see on the map here in the middle. So this is informing conservation processes and also showing that it's important to change the conservation strategies from fixed areas towards dynamic areas that actually follow the path of these top predators, because we can take into account, using these models, environmental pressures such as fisheries and such as climate change. So we're going towards a dynamic approach here. So I think, also I'm almost done with the presentation, but I think we really need at this point some hope and some perspective. In terms of hope, there is this coherence within the scientific community in Antarctica. We work a lot with open access systems, with collaborative systems, with high-end complicated approaches. So there's this rich Antarctic culture that's actually linked with the Antarctic Treaty. And there's also a need for coherence, I think, in the way we do science. So this picture is a picture I took on board a vessel, sailboats, which I took to the Antarctic to try and test the concept of using agile, nimble, and low environmental impact platforms to do work on biodiversity research in Antarctica. So this is an example of the kind of action we can really take as scientists. I'm not saying this is replacing icebreakers, but it's complementary, and this is something we can do on top of the regular work we do in Antarctica. So finally, last message, the priorities for conservation have been really clearly identified. Even if there's a lot of lack of knowledge, we need to go towards dynamic approaches for protected areas. We need to go towards more data sharing, more collaboration. And we also need, because of the proportion of knowledge gaps we have, we need to use also the precautionary principle in terms of conservation. That's really important. And the fact that only 5% of the Southern Ocean is actually protected, actually in a marine protected area, despite the Antarctic Treaty, says a lot about how much we still have to do in terms of conservation in Antarctica. Thank you very much.
Thank you very much, Bruno, for this very nice presentation. Let's go on to the next presentation, which is on tipping points and sea level rise, presented by Ricarda Winkelmann. Ricarda is Professor of Climate System Analysis at the Potsdam Institute for Climate Impact Research and the University of Potsdam in Germany. Ricarda works on comprehensive understanding of key processes, including subshelf melting, surface mass balance changes, iceberg carving, and ice shelf buttressing. She was a contributing author to the IPCC fifth report on sea level change. And Ricarda, please start with your presentation.
Yeah, thank you very much. As already mentioned, I will be speaking about tipping points related to the ice sheet and shelf dynamics in Greenland and Antarctica. And basically the question at the core of this is, what are the long-term consequences of short-term climate inaction? Next slide, please. So building on what we've already heard about ongoing ice loss in Greenland and Antarctica, and also the sea level projections for the 21st century, I would like to take on a global and long-term view. And I think, to me, there's still a great reminder in this graph here, basically showing us the long-term temperature evolution from the last ice age, about 20,000 years ago, to today, because it is a reminder of what is at stake. There are two things that are really striking about this graph. The first one is that, first of all, we, during the Holocene, so the past few thousand years, we actually have been living and thriving in a very stable climate conditions. And the other point is that the difference between an ice age and today's interglacial, that's roughly 3 to 4 degrees of global mean temperature change. And next slide, please. What we're facing today might be that or even more, and at a much, much more rapid pace. So we can really see that humans have become a geological force and that we have entered the deep Anthropocene. Next slide, please. And one of the reasons why this is so significant is because of the risk of transgressing potential tipping points in the climate system. These are core parts of the climate system in the biosphere and in the large-scale ocean and atmosphere circulations, and also in the cryosphere, which, once we're close to a critical threshold, could lead to a qualitative change from one stable state to another. And the tipping points are a stark reminder that our actions today really matter, because they define the long-term evolution of our global climate, including the ice sheets and sea level rise. Next slide, please. And you could advance 3 times. Thank you. So both ice sheets on Greenland and Antarctica are tipping elements in the climate system. And as we all know, they have a huge sea level potential. So they're truly sea level giants. Greenland currently storing more than 7 meters of global sea level equivalent. And the West Antarctic ice sheet, another 5 meters. And the East Antarctic ice sheet, even the tenfold of that. So more than 50 meters worth of sea level rise that is currently stored in that ice sheet. Next slide, please. So for the Greenland ice sheet, we more and more understand the processes that actually make the Greenland a tipping element in the climate system. And for Greenland, as was already mentioned earlier, currently it's really the positive feedbacks at the surface of the ice sheet that matter and that could drive sustained mass loss in the future. And in the latest IPCC assessment report, it stated that complete and irreversible ice loss could possibly already occur between 2 and 3 degrees of global warming, and almost certainly will occur between 3 and 5 degrees of global warming. So this is a point of no return for the Greenland ice sheet. Next slide, please. And you could start the animation. So for Antarctica, the story is slightly different. We've already heard that there are different processes at play, and we actually don't see one global tipping point, but a sequence of potential tipping points in the Antarctic ice sheet. The first one is crossed at around 2 degrees of global warming, where, as you can see on the long term, inevitably large parts of the Western Arctic ice sheet are lost. And as the warming continues, parts of the Eastern Arctic ice sheet, in particular the marine basins, are also threatened. And then there's another major threshold, somewhere between 6 and 8 degrees of global warming, where surface processes all of a sudden become dominant as well, so that at roughly 10 degrees of warming, we could lose the entire Antarctic ice sheet on the long run. If you could advance 3 times, please. So what you see here is a comparison of the new equilibrium states for a 2-degree world and a 4-degree world, where in both cases, West Antarctica is at risk of becoming ice-free, and for the 4-degree case, also parts of the East Antarctic ice sheet. And what is important, once these ice parts are lost, they don't just regrow, even if the warming is reversed. We would actually have to go back to cooler temperatures than at pre-industrial times to really fully regrow the Antarctic ice sheet on the long run. And this brings me to my last slide. So that really means that both the ice sheets are at long-term risk already within the Paris range of 1.5 to 2 degrees of warming, and they really belong to the most vulnerable parts of the Earth system as a whole. Thank you very much.
Thanks a lot, Ricarda, for this very impressive presentation. We are going now to our last presentation before we start the question and answer session. And it is my great pleasure to introduce Professor Dame Jane Francis to give the last talk on how does polar science relate to European policy. Jane Francis is the director of the British Antarctic Survey, and in 2007 she was appointed Dame Commander of the Most Distinguished Order of St. Michael and St. George. I had to read this, Jane, wonderful. In recognition of her service to the UK polar science and diplomacy. She is also the Chancellor of the University of Leeds, and her research interests are paleoclimatology and paleobotany. Jane, it's your time now.
Thank you very much, Nicole. I'm not going to talk about paleobotany. I'm just going to have a look at how polar science relates to European policy. So that's a slide in the background. So we've heard from many talks today about how the science of the polar regions is really critically important, not just for the polar regions, but for the whole planet. And I think also at the COP meeting in Glasgow, we're hearing already that there's a real sense of urgency. We can't sit around and wait for the science to gradually evolve. We need to do the science fast, and we need to get the results out fast, because they really are critical for governments and for policy makers right now. And you've heard from several talks that one of the big issues in the polar regions is, of course, about the melting of the ice sheets. And there are so many unknowns in that, both for modelers and for understanding how the actual ice sheets are responding to climate change. And the major thing that's going to be affected is the global sea level rise. Now, that's not going to just affect the polar regions. That's, of course, going to affect the whole planet. And the coastal regions, they're not just where a few people live. There's billions of people living on the coastal shorelines that are affected, but it's also where the capital cities have developed historically. It's where there are major supply chains have developed, and it's where there are major industries. And if there is ever a need for governments to link and understand how polar regions are affecting global sea level rise, it's in this topic area now. So we need a huge amount more data. We need to understand what's going on there now and in the future to be able to affect that. And as Bruno said, I don't think we should separate biodiversity from our studies of climate change. The two are intimately related. And those vulnerable ecosystems in the polar regions, some of them are food resources, are fish, but some of them are ecosystems which we may never see again as the oceans warm. And indeed, we do need to protect them in these dynamic marine protected areas. And at the moment, it's quite difficult to get consensus around marine protected areas, particularly in Antarctica and in the Arctic. And one particular area I will mention is the Central Arctic Ocean. The Central Arctic Ocean currently is protected by a moratorium from fishing, but it is a perfect area for scientists to go and work. We need to know what's on the bottom of the seafloor. We need to know what lives there. We need to know what the impact will be when the ice around the Central Arctic Ocean melts. So I think that is a really urgent scientific project to be tackled quite soon. And everything, I think, in the polar regions demands international collaboration. I mean, the Antarctic Treaty encourages that, and there are good collaborations in the Arctic. But I think more than ever, we need the scale and ambition of many countries working together to tackle some of these problems very speedily. We need to share science brains. We need to share the expensive logistics of working in the polar regions. And we need to share sort of the critical modelling and new technologies that are being developed for working in these remote regions. And of course, we need funding schemes to support this. So I think this is where the policymakers can come in and work with the scientists on how we do this ambitious science. I think what COP is showing us in Glasgow at the moment is that the communication between scientists and everyone is really critical. And by everyone, I mean, I don't just mean government leaders, but I mean the public as well. I think the public, that's everyone, that includes us, is realizing that climate change is going to affect every single one of us, wherever we live on the planet. And I think we have a duty as scientists to be able to talk not just to other scientists or even to policymakers, but to the public as well. And I think there's probably more work that could be done with policymakers, scientists working more closely with policymakers, but also with policymakers to try and help scientists and policymakers themselves to talk to everyone, to make everyone able to understand what's happening to our planet. And I think that there's a lot more we could do in that area. And my final point really is about adaptation, because even in the COP news at the moment, you will hear a lot about net zero, you will hear a lot about schemes to stop climate change. We need to stop climate change. We need to stop putting carbon dioxide into the atmosphere. We need to take out the carbon dioxide that we've already put in and bury it somehow. And that's a real challenge and needs a lot of new technologies. But we have to also accept that we're on a pathway to warming that we can't immediately stop. And you've heard all the talks today, and they've all said the tipping points and the things that we don't know. There is a momentum, particularly in those ice sheets and in the ocean, especially in the polar regions, that is going to be very hard to stop. And so there's going to be some years, and we don't know the time span, but some years in which the warming will continue and will have impact on our planet. And I think we need to really work with the policymakers to get people to understand that we can't sit back and wait for net zero. We have to be able to adapt to climate change and help people who are going to suffer the most. And scientists can provide that data to help with the adaptation. Thank you very much.
Thank you very much, Jane, for this very impressive speech. We are going now to the question and answer session and the discussion session. And I hope we have some questions in the Slido. Nevertheless, we start with a question which we have prepared already, and my colleague Joseph will pose the first question on you.
Yes, thank you, Nicole. So the question to start us off is, what can Europe and the EU do to support polar climate research? What is the value of coordination at the European level, and particularly with the perspective of COP and international climate policy?
Who feels free to answer this question?
People also answering questions.
Yeah, the online people, can we see them as well? No? Tamsin, please, and then Jane.
I could just give a quick personal perspective, which is that I absolutely wouldn't be here if it wasn't for EU funding and projects. When I was a postdoctoral researcher, the whole reason I got into thinking about uncertainty for the ice sheets was the EU Framework 7 project, Ice to Sea, who I worked with. Huge project, of course, many institutions across Europe built a huge network of researchers working together, but using lots of different models to compare and explore uncertainty. Then the Protect project that I work in now with Frank and Ricardo and many others is almost has built actually quite directly on that past project. Many of the same people are now in more senior positions, have kind of grown up, I guess, a generation of European scientists working together, knowing each other, sharing ideas. So there's a huge legacy there, which will obviously apply to every one of these projects that has been funded in the past and in the future too.
Thank you. Jane, please.
I'd just like to build on what Tamsin said. I mean, I think collaboration, as I mentioned, collaboration in science is absolutely critical to do big science, ambitious science and speedy science. And I think there are some real world leaders in the European science community that are already working together, but more can work together. But I don't think we should restrict it just to the European community. I think that we need to get all the best brains together. I think we need to link with any other nation around the world that wants to work with European researchers to do the best science possible to help us solve this major planetary problem.
Thank you, Jane. Any comments from you? No?
Okay, then we'll go to another question then. I can't see any on the slide. Oh, we have another one on the Slido just now. So we hear a lot about the impacts of climate change on the polar regions, but are there polar processes, which can help to combat or mitigate climate change, and do we fully understand these?
No one wants to answer. Jane, and then Frank. Yeah.
Well, I'll just start and then I'll hand over to Frank because I'm sure I know what he's going to talk about. So one of the big processes happening is, of course, in the oceans. And at the moment, the oceans are our friends, particularly the Southern Ocean around Antarctica, because the ocean is taking in a huge quantity of heat and carbon that we are generating ourselves. So that heat and carbon, it's a considerable amount that's been taken down into the Southern Ocean. And I think we know from sort of preliminary scientific expeditions that this is happening, but we don't really exactly know where it's going or how long this impact will continue. At some point, if you like, the oceans maybe sort of full up of heat and carbon, and then we'll feel the full impact of the climate warming that we're creating. But perhaps, was it Frank who might want to carry on with that?
Frank, please.
Well, I don't think mitigating, whether the polar regions impacted by climate change will mitigate the climate change through other processes. Well, I don't know. We don't know much about this. Once we start to lose a lot of ice everywhere, things will change, and ocean will change, and ocean currents may change, and atmosphere dynamics may change. So you come into a very unknown world in which there are positive feedbacks that even make the impact stronger, but probably also negative feedbacks. But at this moment, I don't think there is much known about the way that the polar regions help to mitigate global warming. On the contrary.
Thank you. Any other comment? Then we move on with another question.
Yeah, so while relatively small, there are significant impacts on the environment and the climate in terms of emissions from polar research itself. So what is the polar community doing to try and minimize and reduce its own impacts on the climate?
We are. Jane?
Others can join in, but certainly I speak on behalf of the British Antarctic Survey, and we're trying very hard to cut our carbon footprint in Antarctica, particularly because we've got a new icebreaker going to Antarctica, which is quite, an icebreaker is a quite heavy use of carbon-rich fuel. But what we're trying to do is to ensure that all our research stations in Antarctica are as low carbon users as possible by renewing them, insulating them, using renewable energy as much as possible, solar, wind, and things like that, hydropower. We're also, for example, in the ship, rather than sending the ship backwards and forwards, using a lot of fuel to do large tracks and large amounts of travel, we will keep the ship, we call it a mothership. We will set the ship in the ocean at a particular point, and we will use a lot of autonomous vehicles and small robotics and drones going out from the ship to collect data using wind power, wave power, and other types of power. So we're very conscious that we need to ensure that we cut our carbon footprint as much as possible, and particularly using new technology.
Thank you. Bruno?
Just to add on this, so I mentioned in my presentation the idea of using sailboats as research platforms as well. So they're particularly nimble and have a really low environmental impact. So this is something I think complementary to using heavy icebreakers. I think another path also is to make the best use possible of information systems. So to use this data we have to identify exactly where we need to go with the ships to improve the models we already have. So where to go to make the models more robust, better in terms of prediction, etc. We can do this already with the information systems we have. So coupling the two approaches, I think, is quite promising. Yeah.
Thank you.
Great. Thank you very much. I can't see. Yes, there was a question. Oh, we've got a couple of questions through Slido now.
May I read the last one?
You'd like to just go for it, Nicole?
I like this question. So Europe has a Arctic policy, yeah? Everybody, I think, knows that and has saw the new Arctic policy, but what would you think should be included in an Antarctic policy? Frank?
Well, the question is, how do we convince that the Antarctic is important?
Yeah.
And I think in terms of sea level rise, that is crystal clear, because what happens in Antarctica doesn't stay in Antarctica. And this is all because of geodynamics, mass changes. So for instance, if Greenland loses ice, it lowers the sea level in the vicinity of Greenland, but it rises it at the opposite side of the world. So you get in the southern hemisphere a sea level rise due to that melting, but a lowering or less impact in the northern hemisphere and in, like for instance, West European countries. So Europe. However, ice loss in Antarctica has the opposite effect, and there we are. If we have rapid ice loss from the West Antarctic ice sheet, it will be essentially Western Europe and North America that will be impacted by a sea level rise just because of that equilibrium.
Thank you. That's interesting. Bruno, yeah?
Yeah, also I think in terms of difference and interest of the Antarctic system, is that it's like an open-air, giant ecology, marine ecology laboratory, where you can assess a unique area where you have most of the pressure, most of the environmental pressure is due to climate change. And you're sort of almost rid of other interfering factors such as pollution, etc., which is much lower than in the Arctic. So that's one really scientific reason. Another reason, I think, or category of reason is the culture of the Antarctic Treaty. So this, I think the treaty is really genius by many ways, in terms of promoting collaboration, promoting open science. And this, I think, is something, it's a model that can be transposed to other areas with a lot to earn in terms of efficiency.
Thank you. Very interesting. Are there any other comments? Ricarda, please.
Thank you. Building on what Frank and Bruno just said, I think there are actually 3 reasons why we all should care about Antarctica. The first one is, as Frank already mentioned, the vast sea level potential and the fact that sea level rise from Antarctica will actually hit us on the northern hemisphere even more than on the southern hemisphere. The second reason, I think, is the fact that the polar regions are really amazing climate archives. So we get a lot of our information about the past and also potential future trajectories of the climate from the ice sheets, and in particular also Antarctica. And the third reason is that while they're an amazing climate archive, they are also our best early warning systems. So they can really tell us, the polar regions, what's at stake and what we can expect for the rest of the climate system.
Thank you very much. We have one last question, and we ask you for a very short statement.
Yes, just a very quick fire answers from all of our panelists would be fantastic. And our question is, what, from your perspective of polar research, what are your expectations or what are your hopes from COP26 this year in Glasgow?
would like to give a short statement? Tamsin, please.
I suppose expectation is maybe different from hope. But I hope that the final pledges, the final nationally determined contributions, do get to 1.5. I don't know whether they could get as low as that, but every 0.1 degrees of warming that we commit ourselves to in the future, as we've heard, increases the risk greatly of losing large parts of both ice sheets. And so every 10th of a degree counts, and we hope that those NDCs will keep ticking down to reduce those 10th of a degree.
Does anybody else has a comment, a final comment? Then we are at the end of our session. I would like to thank all of you very much for these very impressive presentations. I have to say, I learned a lot in this hour about the Antarctic, its melting, its biodiversity. Let's hope that the COP will give a good outcome and good results for all of our future. And again, thank you very much for attending this session. That is.